I hope you're doing well. Welcome back to our today's lesson. I want to take you through a few areas in chemistry that requires the knowledge of valency, so that as we move on, you'll be keen on the knowledge of valency, knowing the areas where you will require it. One of the area where valency is needed so much is in the writing of chemical formula. And make sure that you're writing good notes. In the writing of chemical formula, this one, the knowledge of the valency, determine how elements combine to form compounds. For example, when you are forming potassium chloride, you require the knowledge of valency. So make sure that you're writing good notes in each and every part of this video. So the first one is when you're writing chemical formula of different compounds. So let me give this example of when you're forming potassium chloride. Potassium, this is the symbol. It is in group 1, now that it has atomic number 19 with the 2.8.8.1. So it will be required to lose 1, so meaning valency is 1. So potassium, you indicate the valency at the top there. For chlorine, which is atomic number 17, it has 2.8.7, required to gain 1 electron. So again, valency is 1. So again, you write chlorine and the valency 1 there. So from there, the two valencies are supposed to be exchanged, and each to take the valency for the other one. So this one goes there and this one goes to chlorine. So you end up with capital K1. This one is the one that came from chlorine, and chlorine took the one that came from potassium. And then when you have this one, you cancel them out, so the formula becomes KCl. So the knowledge of valency is very, very important, because when you're writing chemical formula, you must know the valency of different elements, and so that you can end up with a very correct chemical formula of different compounds and even gases, and even any other type of a substance that you might be needed to use when you're writing the chemical formulas. The second area where the knowledge of valency is needed is when you are naming chemical compounds. When naming chemical compounds, or rather what we call nomenclature, the naming of chemical compounds. This is seen mostly for some of the transition elements that have more than one valency. For example, we have iron 2, and we also have iron 3. We also have copper 1. Then we have copper 2. Some of them are examples of transition elements like iron, iron 2, iron 3. And when you use these elements in the writing of chemical compounds, for example, you need, to write the formula of iron 2 chloride, you will first of all write the formula for iron, then take this one to be the valency for iron, and then chlorine as usual has valency 1, as we have seen in the first point, and then you exchange these valencies. This one that was for chlorine goes to iron, and this 2 that was for iron goes to chlorine, and then from there you go to iron, taking the 1 for chlorine, and then chlorine takes the 2 that was meant for iron. Then anywhere where you see a 1, you ignore it, and then you end up with capital F, small e, Cl, and a 2, and you end up with the correct formula. And after you have written the correct formula, then you are able to give the name. Because you used iron when it had the valency of 2, then this one becomes iron 2 chloride. So if you had used the iron that has a 3, then it could have been iron 3 chloride. So in the naming of chemical compounds, and you can now try the writing of the formula for iron 3 chloride, and then you write the correct name. The third area is in the balancing of chemical equations. When you're balancing chemical equations. In this area, the knowledge of valency will assist us to know how many atoms of each element is needed, and so that we can have an easy time balancing each and every atom on each side, on the reactant side and on the product side. Let me give an example of this equation. When carbon reacts with oxygen to form oxygen gas, of course, we need to write the word gas, and so that we can form carbon 4 oxide gas. Before we move to the writing of the chemical equation, I need to show you something here. You see this word gas, this one, that is in the name carbon 4 oxide gas. It is supposed to be written at the point where I have written it. It is supposed to be, because it is a part of the name for the product side, it's supposed to be after the head of the arrow. If you make a mistake and then you come writing it on the other side, like you write it there, and so you read, in your mind you are like, this is carbon plus oxygen gas plus carbon 4 oxide, and then because the word gas never was not able, the word gas did not fit at the end, and then you come writing it on this side. It will be very wrong, because when you write, when you look at this point where we have the tail of the arrow, this side, this one is considered to be the reactant side. So you see the word gas, which is supposed to be for the name on the product side, it has come to the wrong side where we have the reactant side, so it will be very wrong. So instead, you are supposed to arrange your work in a way that anything that is supposed to be on the product side should just be there and not taken to the reactant side. So the word gas should be there because it belongs to the product side. So for that example, when you are balancing chemical equations, of course you need to begin with the word equation. This is the word equation for that reaction. Then we go to the chemical equation. The chemical equation for this case, we must write the formulas using the chemical symbols. So for carbon, that is capital C, it is in the solid state, plus oxygen gas. Though the name reads oxygen, we cannot just have it as one single atom. For oxygen, they must be two. Now that oxygen is a diatomic molecule, diatomic meaning that two atoms of oxygen must combine to form oxygen gas. Then to the product side, we have carbon 4 oxide gas. So now the formula for carbon 4 oxide gas, that is where the knowledge of the valency is coming in. So let us together form carbon 4 oxide gas before we write it at this point. So down here, that is where we are trying to write the formula for carbon 4 oxide gas. So carbon, from the name, we are already given a clue of what the valency for carbon is. By the way, this number that is usually written into bracket here, this 4, it can stand in for both the valency and also the oxidation number for carbon in that CO2 gas. So we take the valency to be 4. And just to remind you, carbon is a metalloid. It is usually in group 4, and it can gain 4 or lose 4. So the valency is actually 4. Then for oxygen, in group 6 is required to gain 2. So the valency is 2 for oxygen. If you have not yet watched the previous videos about how we determine valency from the ions and also from the electronic configuration, you are not late. You can just click the previous videos and you will understand more. So in our previous lessons, we already said that oxygen being in group 6, it is required to gain 2 electrons, so the valency is 2. So then you exchange them. So we got to this point where carbon takes the 2 that was for oxygen, and oxygen takes the 4 that was for a carbon. From there, we look at these two numbers, and because they can cancel each other, we say by 2 1, by 2 2. So from there we have a C, which is for carbon, then 1, and then O 2. And then as usual, where there is 1, you ignore it, and so the formula for a carbon 4 oxide gas remains as CO2, because you have just ignored this one. So C is already 1 here, even without the 1. You see, the reason as to why we cancel this one is because whether it is there or not, carbon is just 1. Oxygens are the ones that are 2. So we come back here and we indicate the formula for CO2, and then we have to indicate the state symbols. Now that we are writing a chemical equation, this is gas, this is also a gas. And then, because the point was that when you use the knowledge of valency, we are able to balance the chemical equation. We will check to see if each and every element is balanced. So right now this equation is self-balanced. Carbon is 1, carbon is 1 on this side, oxygens are 2, and oxygens are 2. So you see, if we had misused the knowledge of valency, or in case we didn't know what valencies to use for which element, we could not have ended up with the correct chemical equation. So that is how we use that knowledge of valency where you are balancing the chemical equations. Other areas that need the knowledge of valency include formation of ions and radicals. You can check on ion formation in our previous lessons. And when we talk of radicals as well, we had them in our previous lessons. And we already said that radicals are a group of atoms that react as a unit, and they usually have an overall charge. And for you to form the radicals, you still need the knowledge of valency. I'll be showing you more as we move on. The other area, number 5, is structure and bonding. For example, in ionic and in covalent bonding. For example, we can give an example of when you want to form sodium chloride. You must know that sodium is in group 1 with atomic number 11. So 2.8.1 is the electronic arrangement. For chlorine, it is atomic number 17 with the 2.8.7. So this one is to lose 1, so valency is 1. This one is required to gain 1, so again valency is 1. So when you're writing, you want to determine the kind of a bonding that they have. It is already ionic because when you look at sodium, it is required to lose 1, and this is the one that chlorine requires. So there will be transfer of electrons that will be lost from the metal to the non-metal, because whatever the metal loses is what will be gained by the non-metal. So that one where we have the transfer of electrons, it is already ionic bonding. So after you have known the valency, you are able also to determine the kind of structure and also the kind of a bond that will be. So next, number 6. This knowledge of valency can also be used when we are predicting properties of compounds. Number 7, for in periodic table trends down the group and also across the period. Number 8, in stoichiometric equations, those are the ionic equations. And number 9, in the determination of oxidation numbers. So in so many of these areas, I'll be preparing lessons so that you can understand more. So if you need to revise and revise thoroughly, you need to highlight these areas that need the knowledge of valency, so that when you sit down to revise, you'll be very keen in how you do them, the valency. So make sure that you know actually how valencies are determined, and it will be an easy time for you when you'll be doing these other topics. So let us meet in our next lesson as I prepare more questions on the periodic table and even in so many of these areas that we have highlighted. In structure and bonding, the formation of ions, you already did it. I will be giving you more questions on the periodic table. I will remind you on how ionic equations are formed. We will be determining oxidation numbers. I mean, there is a lot that is ahead of us. So I'm wishing you well. Highlight those areas in your notebook so that even when you are free when you have chemistry in your own timetable, you make sure that you are going through these topics and subtopics in our syllabus. So may you have a good time. For the new subscribers, welcome, and please keep on telling very many other students that in here we have a channel where we make chemistry very friendly for all of us. Thank you.